Hello, sir. Karthik, sir.
Yeah, yes, ma'am.
Good evening, sir. Sir, your voice is very low, sir.
The same mic and all I am using.
No, I'm not able to hear you.
Okay, please wait, ma'am. Can you hear me now?
Sir?
Yes, ma'am, I am here. Please wait.
Your voice is very low, sir. It's not audible.
Ma'am, is it audible now? Is it audible now?
Yes, sir. You are audible now. You can start, sir.
Okay, ma'am. Okay. Students, good evening. So,
Good evening, sir.
yeah, good evening. So last weekend I gave you a test containing 15 questions. Okay. So I got information from ma'am that you have some doubts on solutions for those numerical problems. So now you can tell me which question you are having doubt so that we can discuss the solution for that numerical problem. Okay, on that test. On that test containing 15 questions. So if you have any doubt on that, now you can tell me, you can unmute yourself and you can talk.
So,
Yeah, tell me. Yeah.
so how to do the third sum, sir?
Yeah, let us discuss now. I think you are talking about the question. Suppose the charge of a proton and an electron differ slightly, right?
Yes, sir.
Question number 3. Okay. Students, I think you all have the question paper with you. So now I will be reading the question. So you please follow the question if you have the question paper with you. So here what it has been given is that suppose the charge of a proton and an electron differ slightly. One of them is minus E and the other is E plus delta E. If the net of electrostatic force and gravitational force between two hydrogen atoms placed at a distance d, much greater than atomic size apart, is 0, then delta E is of the order. Given mass of hydrogen, that is m suffix h, is equal to 1.67 into 10 power minus 27 kg. This is the question. Okay. So those who are not having the question paper with you, and I will display the question to you also, so that you can understand that very well. So, ma'am, can you make me the host of this meeting? Yeah, thank you, ma'am. Thank you. Students, are you able to see the PDF file which I have opened now? Students,
Yes.
I have started screen sharing. Are you able to see the question? This is the question for which we are going to discuss the solution now. Are you able to see the question?
Yes, sir.
Yes. So this is the question. Suppose the charge of a proton and an electron differ slightly. One of them is minus E and the other is E plus delta E. So what they have mentioned is the charge of a proton and an electron differ slightly. That means for one of them, that is for electron, it is minus E, and for proton, what they are telling is it is having the charge E plus delta E. Okay, usually it is not the case. Practically, when you speak about the charges of proton and electron, both are same in magnitude but opposite in direction. Okay, but here for this question, they have just asked us to consider this scenario. So one of the charges is minus E and the other is E plus delta E. So now, if the net of electrostatic force and gravitational force between two hydrogen atoms placed at a distance d much greater than atomic size apart is 0, then delta E is of the order. Given the mass of hydrogen, m suffix h is equal to 1.67 into 10 power minus 27 kg. What they are telling is, actually they have two hydrogen atoms, and the two hydrogen atoms have been placed at a distance d. Okay, so that's what they are telling here. You have two hydrogen atoms placed at a particular distance d. So now these two hydrogen atoms have the electrostatic force between them. In addition to that, they have the gravitational force between them also. Okay, gravitational force, I think you all might have studied regarding the gravitational force in your 11th grade. Okay, so whatever objects are there in the universe, we have gravitational force between those objects. So that gravitational force exists between two hydrogen atoms. At the same time, the electrostatic force is also operating between the two hydrogen atoms. So in this question, they have mentioned that if the net of electrostatic force and the gravitational force between the two hydrogen atoms is 0. Okay, they are placed at a distance d. Two hydrogen atoms placed separated by distance d. Then what is the order of this delta E? Okay, this is what they have asked. So for that, now we will be going for the solution. Okay. So now let me open the whiteboard. So I will be discussing the solution on this whiteboard. Okay. So first of all, they have mentioned that you have two hydrogen atoms apart. Okay, you have two hydrogen atoms apart. So for that, first of all, we need to check what is the net charge on a hydrogen atom. Okay. So the net charge on a hydrogen atom. Are you able to see whatever I am writing on the board, students? Are you able to see that?
Yes,
Yeah.
sir.
Okay. The net charge on hydrogen atom we have to find out first, because in a hydrogen atom you are having an electron and a proton. So in the question they have mentioned that one of the charges is minus E. So let me take that here. And the another one is having, that is the proton is having the charge E plus delta E. So what is the net charge on a hydrogen atom now? It is delta E. Okay, because the electron charge is minus E and the proton charge is E plus delta E. So the net charge is minus E plus delta E. So the net charge is delta E for a hydrogen atom. Now, what is the electrostatic force between two hydrogen atoms placed at a distance d. So what is the sign of this charge here? Sign of this net charge here. Can anyone tell me? What is the sign of this net charge here? Is it positive or negative, students? Can anyone tell me? You can unmute yourself and you can talk. No issues. Yeah, students, you can unmute yourself and then talk. No issues. What is the sign of this net charge on hydrogen atom now?
Sir, is it positive?
It is positive. Okay, it is positive. So you can see here minus E plus E, they are cancelled, and delta E. Okay, it is positive now. Now, please wait. So now they have told that the net force, okay, the net force means the combination of electrostatic force and the gravitational force. Here is 0. Okay. So first of all, I am going to find out the electrostatic force. Electrostatic force now. So Fe. Okay. So that is Fe. So electrostatic force is given by K into Q1 Q2 by R squared is the general formula. In the present case, we are going to find out the electrostatic force between two hydrogen atoms. So this Q1 and Q2, we have to apply the net charge on each hydrogen atom. That will be delta E into delta E. So in the question, they have mentioned the distance between the two charges is d. So this is d square, and this k I am retaining as such. Okay. So this will be now k into delta E the whole square divided by d square. Okay. This is the electrostatic force between the two hydrogen atoms now. Okay. So this is actually E. So you should not confuse yourself. This is actually E. Now my question is, we have written the expression for the electrostatic force between the two hydrogen atoms. Now, is it a repulsive force or an attractive force now? Is it a repulsive force or an attractive force? Can anyone tell here? You can unmute yourself and then you can talk, no issues. Is it a repulsive force or attractive force? Even if it is wrong, then no issues. So you can interact here. You can unmute yourself and you can talk. So the electrostatic force here, is it attractive or repulsive?
Sir, repulsive.
Yeah, you are right. It is repulsive. Okay, it is repulsive. So the electrostatic force here is repulsive. Now we are going to find out the gravitational force. Okay, gravitational force. So gravitational force, let me represent as F suffix G. And for that, we have to apply this formula. G into M1 M2 by D square. Okay. This is the formula for gravitational force. And this thing you all might have studied in your 11th grade. So G into M1. M1 is the mass of one hydrogen atom that has been mentioned as MH here. And the another mass is also another hydrogen atom. So MH into MH divided by D square. So this will be G into MH the whole square divided by D square. Okay. So this is the gravitational force between the two hydrogen atoms. Now you can tell me what is the nature of this gravitational force? Is it an attractive force or a repulsive force?
So attractive force, sir.
Yeah, excellent, excellent. This is attractive force. Okay. You all know very well gravitational force is always attractive in nature. So let me take it as the negative sign. Actually, the attractive forces are actually represented by negative sign. So in the question, they have given you that the net force, that is the force due to electrostatic repulsion and the gravitational attraction, the net force between the two hydrogen atoms is 0. It has been given in the question. So since the repulsive force is electrostatic, I am taking it as positive. The gravitational force is an attractive, so attractive in nature, so I am taking it negative. So this is 0 according to the question. This is nothing but K into delta E the whole square divided by D squared minus G into MH the whole square divided by D squared equal to 0. Okay. So this implies we can take LCM of the two fractions. The D squared will be removed. Okay. The D squared will be removed. So we are left with K into delta E the whole squared minus G into MH the whole square equal to 0. So now we have to find out the order of delta E. So for that, I am keeping delta E on the left hand side. Okay. So K into delta E the whole squared equal to G into MH the whole square. So I need the value of delta E actually. So I can take K to the other side. So delta E whole squared equal to G into MH squared by K. Okay. So now what you have to do is you have to apply the values of G, K and MH. Okay. So G is the gravitational constant, you all know very well, and K is the constant which we use in Coulomb's formula, that is 9 into 10 power 9. Okay. So that thing we have to apply. So let me move on to the next page. So here delta E whole squared is equal to G into MH square. G is nothing but 6.67 into 10 power minus 11. That is the gravitational constant value into MH squared. MH is mass of hydrogen atom. So that has been given in the question itself, 1.67 into 10 power minus 27. You have to square that whole divided by K value. Okay, K value, that is 9 into 10 power 9. Okay. So when you apply all these values and then you have to take square root, because The delta E we need, so here it is delta E squared. So after applying all these values and simplifying, you have to take the square root. So once you take the square root, you will be getting 1.437 into 10 power minus 37 coulomb. This is the value of delta E. So in the question, they have not asked you the exact value of delta E. They have asked you what is the order of delta E. That means in the exponential notation, what is the 10 power? Okay, that is multiplied with the value. So here we have 10 power minus 37 coulomb. So option C. Okay, in the question it has been given 10 power minus 37 coulomb in option C. So here option C is the right answer for this question. Okay. Do you all understand this, students? Anyone having any doubt here?
No, sir.
No, sir.
Okay. Has everyone understood the solution for this problem, students?
Yes, sir.
Yeah. Anyone having any difficulty with the solution, you can unmute yourself and you can tell. Okay. Have you all copied down the solution? Actually, now,
Yes, sir.
if you have any
Yes,
doubt, you
sir.
can copy that down. Yeah, right. Okay. Now you can tell me what is the next question that needs to be discussed here. In that test, do you have difficulty in any other question?
So question 5, sir.
Yeah, question number 5 we shall discuss now. Yeah. Question number 5. Let me read that now. Before that, I think I can stop screen sharing and I will show you the question now so that you can understand it better. Okay. Are you able to see the PDF file now? Students, are you able to see the PDF file which I am sharing on screen right now?
Yes, sir.
Yeah, good. So this is the question. Students, two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is R. Now the strings are rigidly clamped at half the height. The equilibrium separation between the balls now becomes, okay, two pith balls. Pith balls means they are spherical in shape. So two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is small r. Now the strings are rigidly clamped at half the height. So the equilibrium separation between the balls now becomes. So initially we have to draw the diagram. Okay, then only we can understand the problem. So first of all, we have to draw the diagram for this question. Let me draw the diagram. So for that, I will be opening the whiteboard again. Okay, the same whiteboard I am taking now. I will be taking a fresh page. So here they have mentioned two pith balls. Okay. So here in this whiteboard, let me see. Yes, we have the option to draw the circle here. So the initial scenario, let me draw. Okay, the initial scenario. two pith balls are here. Okay, so it's actually spherical in shape. So okay, two pith balls are here. They are initially suspended, and the equilibrium separation between them is R now. Okay, so this separation, this separation is actually R. Okay, and they have given the height also, or the string length. Okay, string length is actually equal. Now the strings are rigidly clamped at half the height. Okay, the strings are rigidly clamped at half the height. So initially, let me consider this height as y. Okay, so this height, let me consider as y. This height is y. So this angle will be theta. This angle will be theta, so that this angle will also be theta. So this height is initially y. Okay. This height is initially, it is y. So then they are actually clamping these two bars at half the height. That means now the height will be y by 2. Okay. Now the height will be y by 2. So y by 2 means half the height. Okay, half the height. So that the equilibrium separation distance changes now. The same pith balls. But now it is clamped at half the height. Okay. Now it is y by 2. Initially it was y, now it is y by 2 according to the question. So this equilibrium separation now we have to find out, and we don't know what is the separation now. So that's what we have to find out. So this thing, so let me take it as r prime. Okay, so the equilibrium separation now, let me take it as r prime. right? Similarly, this angle might also have changed. So initially it is theta. Now let me take it as theta 1, and here also it is theta 1. So we have to find out this equilibrium separation R prime now. For that, we have to apply the equations. So here I will be writing the equation. So here you will be having the tension, right? The tension. Okay, the tension. So when you resolve this tension, you will be having a component here. Okay. So this is also theta. This is also theta. So this will be T cos theta. And it is balanced by the weight of this ball, mg. Okay. And this component, this tension component is T sin theta. That will be balanced by electrostatic force between the two pith balls. Let me take it as Fe. Okay. So let me write the equations here so that you can understand it well. So that Fe is the electrostatic repulsion force or attraction force between these two pith balls. So that is balanced by T sin theta component. So T sin theta equal to Fe, and T cos theta. Okay. So here T cos theta is balanced by weight. So when you divide both these equations, you will be getting tan theta equal to Fe by mg. Okay. Similarly, you can use the equation here, tan theta prime, tan theta 1, let me take it like that, tan theta 1 equal to Fe prime divided by mg, because the electrostatic force now changes because of the change in equilibrium separation. So that I am taking it as Fe prime, but the weight of the ball doesn't change, so it is mg. Okay, tan theta equal to Fe by mg, tan theta 1 equal to Fe prime by mg. Okay. So now what I can do is I can divide this equation by this equation. Okay, Fe by mg divided by Fe prime by mg. Okay, so Fe by mg divided by Fe prime by mg is equal to tan theta divided by tan theta 1. So the mg will be cancelled now. So what you will get? You will be getting Fe by Fe prime is equal to tan theta divided by tan theta 1. Okay. So this is what you will be getting. And the tan theta value in the first case, okay, the tan theta value in the first case, it is actually opposite side by adjacent side. So let me take this right angle triangle here. So this right angle triangle, in this right angle triangle, it is R by 2 now. Okay, this is R by 2. This is R by 2. So this is a right angle triangle. So in this right angle triangle, okay, so this is the right angle triangle now. So in this right angle triangle, you can take the tan theta value. Tan theta is equal to opposite side by adjacent side. So tan theta opposite side is R by 2, half of the equilibrium separation in first case, divided by opposite side by adjacent side, that is y. Okay. Similarly here, you can take this right angle triangle now. So this right angle triangle you can take. Here you will be having r prime by 2 as the opposite side. Okay, r prime by 2 as the opposite side here in this right angle triangle, r prime by 2. So here we can write tan theta 1 is equal to r prime by 2 whole divided by, one second please. Yeah, sorry for the interruption. Okay, so here this tan theta 1 is equal to r prime by 2 divided by the adjacent side, that is y by 2. Okay, so tan theta is here, r by 2 by y, tan theta 1 equal to r prime by 2 divided by y by 2. You can apply both these values in this equation, that is fe by fe prime. Okay, you can apply both these things here. So now I will be writing this. So f e divided by fe prime equal to tan theta is r by 2 y actually. Okay, from this you can see so this is r by 2 divided by y, that is r by 2y. Okay, r by 2y, that's what I have written here. This is r by 2y whole divided by fe prime, that is tan theta 1, that is r prime by 2 divided by y by 2, that will be r prime by y. So here you can write r prime by y. So now fe by fe prime equal to r by 2y divided by r prime by y. So from this you can cancel out the terms which you can cancel. So the y will be cancelled. Okay, y will be cancelled. That means r by 2 r prime, this is equal to fe by fe prime. Okay, so now we have to find out this ratio, this fe by fe prime ratio we have to find out. From that we can arrive at the value of the equilibrium separation r prime. Okay, so let us consider that the charges on each of these balls is q. Okay, the charges on each of these balls is q. So according to Coulomb's law, okay, according to Coulomb's law, fe is equal to k into q squared by r square. Okay, according to Coulomb's law. In the second scenario, that is the equilibrium separation is r prime. So here the charges are not different, the same value of charges. So k q squared divided by r prime squared now. Okay, this is r prime squared. So now what you can do is fe by fe prime you can apply. So fe by fe prime, okay, is equal to k q squared by r squared divided by k q squared by r prime square. So that is equal to r by 2 r prime, that we have already written here. So from this equation it is r by 2r prime. So here you can cancel out this kq squared and kq squared, and then this r prime squared will go to the numerator and r squared will come to the denominator. So r prime squared by r squared equal to r by 2r prime. Okay. So now what you can do is you can cross multiply, go for cross multiplication. So here what you can do is you can take square root actually. For the left hand side of the equation, you can take square root. So while taking square root, what you will get? You will be getting r prime by r equal to r by 2r prime. So this implies 2r prime squared is equal to r squared, and this implies r prime squared equal to r squared by 2, and we need r prime equal to r by root 2. Okay, r prime equal to r by root 2. So this is the correct answer for this question. That is option B. Okay, r prime equal to r by root 2. This is option B. I hope you all understood the solution for this problem. Students, do you all have any doubt regarding this problem? Do you have any difficulty in understanding? Students, you can unmute yourself and talk in case if you have any difficulty in understanding this problem.
Sir,
Yes, tell me.
sir, could you explain that final part, sir?
This thing, okay, I will do. So this r prime squared, right? R prime squared by r squared equal to r by 2r prime. This step or this step you are asking about? Which one?
Sir, the previous one, sir, that Fe is equal to kq square by r square, Fe dash Fe prime is equal to kq square by r prime square. From there, sir.
From there you don't understand. Okay.
Sir.
Let me write it on other side, other page actually. So here Fe equal to k q squared by r square. Fe prime equal to k q squared by r prime square. Do you understand this step now? This step only. I am asking about this step only. Do you understand this? So the next step is, we know very well Fe by Fe prime. Okay. The previous step. Fe by Fe prime equal to r by 2r prime. Okay. So this is the equation which we arrived from the tan theta equations. Okay. So Fe by Fe prime equal to r by 2r prime. So this step we have arrived from here. Okay, you can see Fe by Fe prime is equal to r by 2r prime. So this step we have already arrived based on the tan theta equations. So now we have to apply this Fe and Fe prime in this equation. That is k q squared by r squared whole divided by k q squared by r prime the whole square equal to r by 2r prime. Now this kq squared and kq squared will be cancelled out. And here this is in denominator of the denominator. This r prime squared is in denominator of the denominator. So this r prime squared will be taken to the numerator and this r squared will come to the denominator. So r prime squared divided by r squared equal to r by 2r prime. Okay. Then what you can do is you can actually take square root of the entire thing, or you can apply square root for the left hand side of the equation alone. You can do. Okay, you can take square root. So when you take square root, you will be getting r prime by r equal to r by 2r prime. So this implies r prime square is equal to r squared by 2. Okay, this cross multiplication you have to do here. So this 2 I am keeping it on the right hand side of the equation, and this r prime will be taken to the left hand side of the equation, that is r prime square, and this r will be taken to the other side. So cross multiplication r squared. So r prime squared equal to r squared by 2. So now we need the value of r prime only. So we have to take square root on the other side. R prime equal to r by root 2. This is the answer.
Yes.
Now do you understand this?
Yes, sir.
Ah, good.
So the option will be 1 by root 2.
R by root 2 actually.
Yes, sir. Okay, sir.
R by root 2, and that is option B, I think. Yes, option B. Anyone have any difficulty on understanding this problem? So I think you all understood this solution. I think you all understood the solution for this problem. Okay. So any other question from the test which you want me to discuss? Yes.
So question number 9, sir.
Question number 9. Okay. So question number 9 is something related to the continuous charge distribution. Okay. So for that I am closing this whiteboard, and I will show you the question actually. Question number 9, you can see here. So you have to use continuous charge distribution concept here. So here you see the charge wire is bent in the form of a semicircular arc of radius A. If charge per unit length is lambda coulomb per meter, then the electric field at the center O is. What they are doing is they are taking a charged wire and they are bending it in the form of semicircular arc of radius A. Okay. So then we have to find out the electric field at the center of this semicircular arc. Okay. So now for that we need to make a diagram. So let me open the whiteboard. Let me go for a fresh page. Okay. You can create up to 12 pages in this whiteboard. Okay. So for that we have to draw a semicircle first. So this is the circle, and the charged wire is bent in the form of a semicircle. So let me draw the semicircle manually here so that it will be better now. So this is the semicircle. Okay. So now we have to find out the electric field at the center. So let me take here the radius is A. Okay, the radius is A. So we have to find out the electric field at the center O. Okay, due to the charged wire. So here you are having the whole portion of this semicircular arc. So you can consider small length elements along this arc. Okay, small length element means you can take DL. Okay, you can take DL like that, and DL will be producing an electric field at this point. Okay. Similarly, you will be having a DL here, symmetrically opposite side, and this DL I am considering it as A, point A, and this DL I am considering as point B. So this DL will also produce an electric field like this. Okay. So let me take it as DE1 is the electric field due to this length element DL, and the symmetrically opposite element DL will be producing an electric field DE2. Okay, and the angle here, let me take it as theta. Okay, so by symmetry, what will happen here is, so here you will be having the cos theta component of this DE2 and DE1. This is the sin theta component. Okay, this DE2, this will be theta, this will be theta as well. So the opposite angles. So this is theta and this is also theta. So this DE2 can be resolved into DE2 sin theta here. So DE2 sin theta here. And this DE1 can be resolved into DE1 cos theta here. Sorry, sin theta here. Okay. And this thing you can make like this. So this will be DE1 sin theta. And here you will be having DE1 cos theta and DE2 cos theta along the same direction. So DE cos theta will be along the same direction. So DE1 E2 sin theta, DE1 sin theta equal in magnitude but opposite in direction. So they will be cancelled out. So the DE cos theta will survive. So the electric field will be, you need to apply. So DE equal to DE cos theta equal to actually 1 by 4 pi epsilon 0 dq by A squared into cos theta. Okay, this is dE cos theta. Because this dq is charge, A is the distance. Usually electric field due to a point charge is given by q by 4 pi epsilon naught r square. So here you are having a cos theta component also in addition. So now this dq we need to find out. That will be lambda into dl, because lambda is the charge per unit length. When you multiply this with the element of length, you will be getting the charge. So lambda dl by a squared into cos theta. So this dl is actually an arc length. Okay, this dl is actually an arc length, and this arc length can be found out by dl equal to a into d theta. This radius into d theta. Okay, this dl arc length. So is 1 by 4 pi epsilon 0 into lambda into a d theta divided by a squared cos theta. So this is 1 by 4 pi epsilon 0. So this is lambda by a, now cos theta into d theta. This is the electric field due to the small elements. So whenever you want to find out the total electric field, you need to actually integrate this thing. So the total electric field is given by E equal to integral dE. So these limits are minus pi by 2, pi by 2. Okay. So here it will be minus 90 degree to plus 90 degree. You can integrate. So here you have to go for the integration. That this minus pi by 2 to plus pi by 2, you can change the limits 0 to pi by 2 into lambda by 4 pi epsilon naught a. Okay. A into integral that is cos theta d theta. So you can take all the other terms outside. So 2 lambda by 4 pi epsilon naught a into integral cos theta d theta, that will be sin theta, and you have to apply the limits minus pi by 2, pi by 2. Okay. Sorry, minus, this is not minus pi by 2, that will be 0. Okay. This will be 0. So this is pi by 2. Okay. This is 0. So 2 lambda by 4 pi epsilon naught a will be lambda by 2 pi epsilon naught a. So this is sin pi by 2 minus sin 0. So this will be sin pi by 2 value is 1. So here lambda by 2 pi epsilon naught a. This is the value of the electric field. Okay. And I think you have the option there. That is option C. Okay. I think we are running out of time. You have to join the next class. So this is how you need to solve the problem. Thank you so much, students. And if you still have any doubt regarding any of the questions on the test, you can ask me in the next class. Thank you so much.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Thank you, ma'am. Thank you. I am making you the host of this meeting.
Okay, sir. Okay, sir. Children, please join in biology class.